In this demo, we want to see a couple of more examples of processing a string data type using loops. So the first problem is to count all the tokens in a given string. Considering this sentence as a string, if we split it by spaces, each of the segments is a token. So we don't care if it's a number, it's a word, it's a punctuation which is separated by a space. We just need to count the number of tokens. So we're gonna just declare a variable and read it, and then define a variable token counter. And since we need to iterate over all the characters of the string, we can use for structure and check all the characters one by one. This code has a logical error that I want you to try yourself and see if you can find it. In the first try, I assumed that all the tokens are splitted from each other by a single space. So I can only count the number of spaces, and number of spaces plus 1 would be the number of tokens. So if text at index I is equal to space, I'm going to increase the token counter. Finally, I'm going to print the token counter. But before printing, I need to increase it by 1. So let's run it and see what's wrong here. So I'm gonna test with this sentence. So the output is 1, which means that this loop doesn't change the value of token counter. Why is that? Let's check the text and its size here. So I'm gonna print text and text dot size. We only got the text up to the first space because we used scene function. If you remember, in the second chapter, we learned that if we want to read a line, we need to use getLine function. So we are gonna change it. And see the difference. Now we successfully read the entire line, and the number of tokens are also correct. Now we need to improve the code to handle the cases in which we have 2 spaces in a row. So if I have 2 spaces here, it counts 3, but we have 2 tokens. So we need to add more constraint. So I'm just gonna remove this 2 line, we don't need it anymore. We can fix this problem by making sure that the next character to this space is not another space. So I can just add ands here, and we need to make sure that I plus 1 is smaller than text.size so that we don't get out of bound error. And then we check the next character and make sure it's not in a space. Now it works perfectly. The most important point here is the order in which we check these 3 conditions. We talked about short circuits, and you know that when we have AND of a couple of expressions, when the first one is right, the rest of them will not be evaluated. Here, the first thing that we need to check is if the character is a space or not. If it's not a space, we don't need to check the rest of the conditions. So this one should be first. Between these two, we need to check this one first to make sure that we don't get out of range error. So if I change the order here, and try something that has a space at the end, I get out of range error. So it's important to check if I plus 1 exists and then check its value. We still need to handle one case. If our string starts with a space, we will get the right result. So we need to check if the space is a leading space or not. It's a bit ugly, but we can use a Boolean variable to check if we have seen any character except spaces or not. So if the starting space is false, its negation will be true. And text at I is not equal to the space, we're gonna set the starting space to true. In this way, we can handle multiple spaces in the beginning. And we also add a starting space here. So let's see what happens. So we can handle one space. Let's see if we can handle multiple spaces. Yes, we can do it. So again, we need this flag because whenever we have a space and after the space we see a character, we will count it as a token. But in the case of starting the spaces, we shouldn't count it. So in order to handle this, we just need to check if this set of spaces are starting spaces. So if we haven't seen any character except for spaces so far, this expression will be evaluated to false and we don't increase token counter. But as soon as we see any character except the space, we're gonna change it to true so that we count the rest of the string correctly. The next problem is to capitalize the first letter of each word of a given string. The problem asks us to assume that words are separated by single space, but we can also handle multiple spaces. We can use the same structure. Here this statement will be applied to all the spaces after which we have a non-space character. So we can use this branch to change the character at position I plus 1 to uppercase. The only case that we are missing here is the leading non-space character. But the leading non-space character will enter this branch. So we can just copy it over here. But here I is a non-space character, so we need to apply it on I itself. And then we just need to print the text and include CC type. We don't need token counter anymore. So let's run the code. and test it with the sentence. So it capitalized all the first letters, and we can also test it with a string that starts with leading spaces. So it works perfectly.